going to go over the solutions to the probability quiz 13.1, and I'm going to do it without a calculator. Number one, if a code name is to consist of 3 letters taken from A to Z, followed by 4 digits, and no digits are allowed to be the same, then the total number of possible outcomes or possible code names is, alright, so 3 letters, so there's 26 letters in the alphabet, so it'll be 26 times 26 times 26, and then followed by 4 digits that can't repeat. So there are 10 digits, 0 through 9, and then I can't repeat, so then there's only 9 left, and 8, and then 7. And so that's what I would multiply together, and so now I'm looking at my answer choices, and I see that that goes with B. 26 to the third power is 26 times 26 times 26. All right, number 2. Put 6 factorial, so 6 times 5 times 4 times 3 times 2 times 1. That's your 6 factorial over 6 to the power 6. And now we reduce it, divide by 6. 3 times 2 is another 6. 4 is 2 times 2, so I'm going to divide this by 2, and I'll divide this one by 2. And we're left with a 5 over 9 times 36, which is going to be 5 over 36 times 9. 324. There we go. No calculator. All right. Number 3. In how many different ways can the 7 letters in the word minimum be arranged? So there's 7 letters, so 7 factorial, and I'm looking for repeats. I have 3 M's, got 2 I's, and that looks like it. And so then I work on reducing this. So 7 times 6 times 5 all the way down. We're going to end up with 77 times 6 times 5 times 2. So 7 times 6 is 42. 5 times 2 is 10, and so that's going to be 420. B. 4. How many ways can you choose 3 donuts from 3 different types? Order doesn't matter, and repeats are allowed. Okay, so 3 donuts, 3 from 3 types. So let's say you got type A, B, and C. So I'm gonna list this one out so we can have all the same type of donut. You can have all. Let's see, we can have two A's, whatever A is. That's a type of donut. So we have 2 A's and a B. We can have 2 A's and a C. Order doesn't matter, so I'm not going to worry about switching order around here. We have 2 B's and an A, 2 B's and a C. You can have 2 C's and an A, and 2 C's and a B. So those are the 2 of a kind. So this is all the same kind. This is 2 of a kind. These are the types. We can have 1 of a kind. A, B, C. There's only one way to do that. Order doesn't matter. And repeats are allowed. So add that up, right? So we got 1, 6, looks like we got 10 ways. My answer is 10. So now I'm looking for, this is 9, this is 27. Looking for which one of these is equal to 10, right? Now let's see, 5 factorial, 5 times 4 times 3 times 2 times 1 over 3 factorial and 2 factorial is going to end up being 10. So this is my answer. Number 5, a certain class has 6 girls and 5 boys. 4 of these students are to line up in front of the room, with 1 girl on each end and 2 boys in between. So we're gonna have girl, boy, boy, girl. How many such arrangements are possible? Okay, so there are 6 girls, so we have 6 and then 5. We got 5 boys, so we got 5 and 4. And then you multiply that together. So what's this going to be? 30 times 20, which is 600. A committee must be formed with 2 teachers and 3 students. Okay, so I want 2 teachers. I'm picking 2 out of 4. So I got 4 options for my first pick, 3 for my second. Remember when we see committee, order doesn't matter, so I'm dividing by 2 factorial. So that's many ways I could do that. And then for students, I'm picking 3 students out of 5. So I have 5 options for my first, 4 options for the second, 3 options for the third. Again, order doesn't matter, so I divide by 3 factorial. And then I'm going to multiply these together. So we end up with 6 times 10, which is 60. How many handshakes are possible between 20 people? So if I'm going to look at one handshake, you got, well, you need to pick 2 people for one handshake, right? So there's 20 options for the first person and 19 options for the second, but it really doesn't matter the order of that. So I'm going to divide by 2 factorial, and we end up with 10 times 19, which is 190. So you can have 190 different handshakes with 20 people. 8, if you roll 2 standard fair dice, what's the probability the difference of the 2 is at least 2? All right. So I'm going to create a table here. I'm going to look at the difference. So 1 minus 1, 2 minus 1, 3 minus 1, so on. All right, so there's our difference table. And so if you roll a standard dice, what's the probability? So the probability that the difference is at least 2. So the difference is greater than or equal to 2. So it's out of 36. And let me how many? So greater than or equal to 2. So you have 4 there, 3, those. All right. And so just count up what I highlighted. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 out of 36. Reduce that. 10 out of 18, 5 out of 9. The probability. 9, what's the probability of getting at least 3 tails out of 5 coin flips? So if you flip a coin 5 times, you can have 5 tails, 4 tails, 3 tails, 2, 1, or none. At least 3 is 3 or more. Okay. And usually when it says at least, you want to think about the backdoor approach, but in this case, it doesn't matter. You got 3 cases either way. So how many ways can you have 5 t's? Well, that's going to be 5 factorial over 5 factorial because you get 5 letters and 5 repeats. Here we got 4 t's and 1 h. So that's 5 letters, but you have 4 t's. It's going to end up being 5. And one more, you got 3 t's and 2 h's. So you got 5 letters, 3 t repeats, and 2 h repeats. So you're going to end up with 10. We get 10, 5, and 1, so it's 16. The probability of at least 3 tails out of the 5 coin flips. At least greater than or equal to 3 tails is 16. You got 5 coin flips, so 2 times 2 times 2 times 2 times 2. Well, that's 16 right there, so we can reduce this to 1/2. There you go. That's the end of the quiz. Hope things are going well.